Yes, Khaled, we can see.
Okay, we'll start. Hello everyone and welcome to session 2 of the swimming pools design course. So we finished the first session already, and if we go in a quick recap about the key points that we discussed in the last session, we spoke about what are the objectives of this course, what are the basics of and the fundamentals that we need to know before start learning how to design. We spoke in general, and also we spoke about the sources of contamination, the importance of pH level, and what is happening if we have disorder in this pH level. Uh, we see types of pools and the different consideration for each one of them. Okay, so we discussed actually like many details that you can check them in the record that I sent you. I believe all of you received this link. Everything already uploaded in the career link. It will be available there. Every session we will go upload the session in the career learning for to be available for everyone. So in today's session, we are going to start to learn about how to start the design, how to do the calculation, and we will see also how the filtration operation happening in videos for deep understanding about every single component as I promised previously. Okay, so let's start. I need here just, yeah. So as usual, the agenda is our main reference to see how we progress in this course. So today's topic is the swimming pool circulation system. As we see here, we are in the session 2. We have 5 sessions, the total number of sessions for this course. So just to remind you about the last topic that we discussed in the last session, because as I said before, it is important. We need to know the difference between the skimmer and the overflow. I will just like very quickly remind you about this one, because from now on we are using this as a reference for all of us. So we have a skimmer type, which is more simple than the overflow type. And this the skimmer type, usually the water level lower than the deck level around the pool, and we have the drain pond skimmers connected directly to the pump. Unlike the overflow, we have here surge tank, like intermediate part between the pool and the pump to accumulate the overflow, and the level of overflow type always the same level of the surrounded level around the pool to give you the impression the water like overflow. So the skimmer look like this, the overflow look like this. So just this like a quick reminder to start this one. So we will start today to know how to design the skimmer type. We'll go through every single component. Okay, we will make hydraulic calculation. We'll do everything. So as you see here, the skimmer is the start point here, and vacuum also. If you don't know the vacuum is like the vacuum that we are using in our home to clean the dust. But here it is like water, wet vacuum. We use it to clean the debris from the bottom here. That's the debris is stuck in the bottom of the pool here. We take it out through pressurized suction pressure through the pump, and then we have the filters, and then we have if we have cooling or heating, we're using here whatever relevant heat exchanger. Here then we have the set of like chemical dosing, all types of chemical dosing to adjust the pH, chlorinator, and so on, sometimes ultraviolet also, and then the water go back clean to be distributed equally in the basin of this pool. Okay, clear? So what I just explained, if we like itemize it or break down like that, in order to design such type of system, we need to start by the pump, okay, the most important one, and then the filter, and then backwash tank if needed. Actually, this backwash tank not common in all designs, but we normally we provided as a WSCB plumbing side, not the swimming pool side, because at WSCB we did not make swimming pool design before. We provided as a temporary as a solution, sorry, for the scope gap between us and the other specialist. Normally they are working alone, focusing only in their scope, and they are not considering the drain connection. And we are working alone also without considering the backwash coming from the pool. And once we reach to the construction, it become issue. So to resolve it, because we cannot connect pressurized drain to our current drain system. So in order to resolve this issue, we invented something called the backwash tank in order to like slow down chamber to accommodate the high pressure volume coming from the backwash when we clean the filter, to make it like same like gravity drain or grav twist to accommodate this one in our network as a WSCB. Okay, so we will check this one also. Drain points, skimmers, vacuum points, main drains. Then we will see how to size the water inlets, how to count, how to decide how many water inlets required based on the pool capacity or the pool size, how to make sizing for the pipes. Okay, even the sterilization equipment, we will see how to calculate this one. Also the heating load that we are using here for heating the pools. Okay, so all of this we will go through them one by one. Guys, any question? As we agreed, if you have any question, raise your hand and I will answer whenever possible. Okay, so now we will start by the pump. Okay, so the pump sizing is one of the most critical components when designing a swimming pool. So this is the heart of the whole circulation system and impacting the sizing of all other components, as we are going to see later. So keep in mind that oversizing the pump can lead to energy waste and increase operational cost, while undersizing the pump may lead to inefficient filtration and inadequate circulation, which is leading at the end to poor water quality. So the right sizing for pumps will help to maintain proper water circulation and filtration, and also help to ensure that we do correct sizing for the remaining system. So everything relying on sizing the circulation pump. If we make it correct, everything will be correct. If it is wrong, it will be followed with the same. So in this session, we'll explore the fundamental steps to properly size the pool pump, the circulation pump, and ensuring optimal performance and energy efficiency for the entire system. I need to stop this transcript. Okay. Okay. So now, how to size a circulation pump? Okay. So in order to select a pump, all of us, I believe, aware about this as a mechanical engineers. This is part from like chilled water system, plumbing, or any system required pump. So we must determine the required flow rate and the pressure. Without both, we cannot select a pump or find pump from the available vendors in the market. Okay, so we have to find the pressure, the flow and the pressure to ensure proper circulation and the filtration is achieved. Okay, so first, what is the flow rate? The flow rate is the volume of water the pump must circulate per unit of time, which is typically measured by a meter cube per hour, as we know. So the pump here should be capable of handling the required flow rate to properly circulate and filter the water of the pool. Okay, so this flow rate typically calculated based on the pool volume and the desired turnover time. Okay, and we'll go step by step. So to calculate the required flow rate, we need to follow these steps. First, we need to know what is the volume of this pool, and it is easy to be obtained. If we have regular shape, lengths, widths, and depths, so simply we can calculate it. If it is irregular, any draftsman can give it to you. So this is the first given data supposed to be available with you in order to start calculating the flow rate. Okay. So the second thing, the turnover rate of the pool. Okay. So the turnover period in a swimming pool is the time required for the entire volume of pool water to pass through the filtration and treatment system one time. Okay. Okay. So we need to filter the entire volume of the pool water one time. The one time called turnover rate or period. Okay. So how many times we should do this one per day? This is the question. In order to answer this one, we have actually different codes and standards. The one that you see in the screen here, this extracted from DM as per the request of many of you in the last session. Okay, correct. Okay. Uh, okay. So the turnover period, critical factor for maintaining water quality and ensuring proper circulation. So the one that you see on the screen, this is DM requirements, but there are different requirements. It depends on the code. It depends on your local code. If you are in Saudi Arabia, if you are in Egypt, if you are in USA, like that. So the standard turnover period in general, in the international codes, for example, private pool, we need to do it within 6 to 8 hours if it is private pool. If it is public pool, from 4 to 6 hours. What does it mean? It means we need to circulate the whole volume within 4 hours or 6 hours, 8 hours, whatever the recommended time here. It has to be followed in my calculation to size my pump. So the pump should be capable to achieve this turnover period. Okay. So if you see here, the laser not coming. Okay. If you see here in the DM code, it is written swimming pool once every 6 hours. So the 6 hours as it is, which is in line with the standard. And the standard telling if it is private pool from 6 to 8. You have as per the design judgment, he can select whatever suitable for him. Public pool from 4 to 6. So 6 is like common for public and private pools. It works. Okay. And for wading pool, and you remember from last session, wading pools equivalent to the children pool. They are telling 2 hours. Hydrotherapy pool, 1 to 2 hours, and so on. Okay. So based on this recommendation, you determine as a designer what is the required turnover rate in order to start sizing your pump. Okay. Okay. So the next step is the flow rate. Now we have the volume, we have the turnover rate, which is time, and we agreed the flow rate. In order to calculate it as a designer, I need to know two things, the volume and the time that we need to pass this volume through the pump. Okay. So once you got both of them, you can calculate the flow rate. The step number 4, okay, which is game was 5. Okay. So step number 4, which is called TDH. TDH, the total dynamic hit. So we calculated the flow. We need to know what is the pressure required in order to select our pump. So the TDH is the resistance to the flow that we calculated of water through the whole system, including pipes, filters, heaters, and any other accessories that cause resistance. Okay. So also we need to consider factors like pipe length, elevation, head, the static head, and also the residual pressure that can be covered with the factor of safety. All of those factors, it has to be considered in order to know what is the suitable pressure for sizing our pump. So calculating the TDH will help us to choose the pump with the right pressure head to overcome the system resistance, whatever resistance that we have here while the flow running. Okay, the pump should be capable enough to push it back and to continue the flow until reach to its destination. Okay. So once we calculate the flow and H, we size the pump already. the last step, the horsepower. This horsepower could be calculated and could be obtained from the catalog. Okay, so then we can choose our pump. Okay, so now let's apply the steps that we learned in practical example. Okay, so imagine if we have pool with this given data. We have 10 meters, 15 meters, depths 2 meters, little like that. So what to do in order to size the pump for such pool? So as we agreed, we need to know the volume. The volume, it can be easily obtained since we know all dimension of this pool, which is 300 cubic meter, as we see here in the screen. Yeah, enlarge this a little. So after that, the turnover rate, he's telling here, this is public pool. So the public pool, as I just said, as per the standard code, it could be from 4 to 6. As per the M code, they did not say public or private, they said 6. Okay, so we need to remember something. When the code give you range from 4 to 6 or 6 to 8, okay, which means you should not exceed this. But if you go below, which means you are much better, okay, and the filtration will be more efficient. Okay, so in order to judge this, you have to see the client requirements if he is ready to pay extra, because as more filtration, which means as more bigger area required for the plant room, as more like oversized, not oversized, like bigger size equipment, pump, filter, everything. So if the client ready to pay for this one, you can make it lower. So if the code say, for example, like the DM code 6 hours, you can make it 5 hours. You can make it 4, 3, 2, 1, as you wish, as long as you are not exceeding the 6 hour, the top level that the DM limited you. So as per the international code, we have from 4 to 6. I will choose 4 for better quality control. So now we have the volume 300 cubic meter divided by 4. So we got the meter cube per hour, 75 meter cube per hour. So one pump with 75 cubic meter per hour would be capable enough to handle the entire volume of this water to filter it completely within 4 hours. Okay, but you know, we are in the construction. We know this is very big pump. We should not select one pump with this with the hose with the whole flow. So you can say this is the system flow, but the pump, it could be divided to 2 pumps, 3 pumps, as we wish to make it a little smaller, and it also as operational wise, if one pump damaged, the others will keep running until it is fixed, and then we can add one standby. We'll see this one. But the most important thing, we know the system flow required this amount, 20.8 liter per second. Okay. Okay. So now the next step, we calculated the flow. We need to know what is the pressure. So as we agreed, the pressure include the static head, okay, the friction losses, the equipment losses that we have, and we can put also factor of safety to be in safe side. So as I told you, I need to simplify the calculation for you, for anyone. Even I see some of you not mechanical. I see architecture and electrical. So if you follow this steps as it is, like blindly, you will be able to design swimming pool. One of the things that the people complicate the hydraulic calculation, go in too much details in this friction losses. So what they will do, they calculate the length of the pipe and they go to charts. I can show you one example to see what is the accurate way. You see here, this chart, we use it to calculate the friction in any system. Okay, so I extracted this from International Plumbing Code, and this in the English units, not in SI units. So they are using GPM, foot, and the stuff. So in order to calculate the pressure drop accurately, you can use this chart. You can use also you can use softwares, many softwares are available on the market. But I will show you the easy way to calculate it, because ultimately the difference, it will not be that much. I will show you the difficult way here, okay, to understand this chart. If someone speak with you with this chart, you will be able to understand him and speak with him like one to one. Okay, so if you see here the left, sorry, I'm not sharing the screen. I was in another screen. You see now the chart, guys. You see the chart?
Yes. Yes, Khaled, we can see.
Okay, so here this chart it contains several information. The GBM here in this side, the friction losses per square inch, okay, per every 100-foot length, okay, the velocities, this one velocity, okay, and here this is the pipe size. So, for example, with the information, with the given data, two information like GBM and the velocity, okay, or the pipe size, you can obtain all other information. So, for example, let's say we have 200 GBM, okay, so, which is almost equivalent to the 20 liter per second that we obtained, okay, and the velocity should not exceed 5 feet per second, which is equivalent to 1.5 meter per second. So you see here, this hit this line. So the friction coming here around 1.5, 1.3, something like that. So what is this? This is the friction losses, okay, pounds per square inch, okay, for every 100 foot. So you need to check the total length of your pipe, the equivalent length of the fitting, and sum all them together, and you multiply this one with the friction that you found it here, you will get the pressure losses, which is something very minimal. It could be like 2 meters, 3 meter, 4 meter. So if you put factor of safety like 10 percent or 20%, it will cover this one. So no need to go in details about this one. So going back again to our calculation, as we see here. So the pipe length here 40 meter, fittings equivalent, it could be like you can say 10% or 15%, okay, of this one. Filter losses, you have to consider the filter, the pressure rapid sand filter. This one, it is very from 0.4 to 0.6 bar, depends on how dirty it is, okay. So let's take the average around 0.5 bar, which is equivalent to 5 meter. We know 1 bar equal 10 meters, so a half bar equal 5 meter. So always consider like that, the filter pressure drop 5 meter, okay. Okay, so first the static head, how much distance, I'm talking about elevation distance between the pump level and the pool level. How much is this one? So most of the pump rooms usually in a level lower than the pool basin, in order to take some of the drains by gravity, and some of them it will be sucked by vacuum. So always recommended like that, the pump to be in a level lower than the pool level, okay, for the pump safety and for better operation and everything. So how much elevation difference between the pump and the pool basin? This is the elevation head that we need to consider in our calculation. So let's assume we have 5 meter in this project, okay? And regarding to the friction the pressure losses calculation in the total length of the pipe that we calculated around 55 meter, okay. So if we consider it is like PVC or HDPE, assume around 10% or 15% of this one friction losses, and no need to go through the calculation that the charts or tables or anything. This it will cover you and make you in the safe side. So this one, it will be around zero point 0.2, which is equivalent 11 meter. Okay, and believe me, if 11 meter is too much far than the reality. If you calculate it accurately through the chart, it will come like 2 meters, 3 meters, something like that. So 11 meter, it is not like that big difference, and it will make us safe. Okay. Okay, so the filter losses we agreed 5 meter, right? So now how to calculate this one? Sum all of them. You have 5 meter, okay, static, the elevation that we agreed, 11 resistance or pressure drop, 11 meter plus the filter losses, 5 meter, 21. Add factor of safety, 10 meter for the residual pressure, because after like overcome all of this resistance, the water should not stop in the in the inlet. It should push the water in the basin outside. So we call it residual pressure, the same like what we have in the plumbing. So the 10% to cover all of this one. Okay. So the final one, it will be around 23. You can round it up to 24 or keep it 23, both of them correct. Okay. Okay. So now we calculated the flow 20, it was 23 or 20, something like that. And the pressure around 23 meter, which equivalent to 0.3 bar. So now we have to calculate the kilowatt, horsepower and the kilowatt, because normally the electrical, I'm talking with you like designers now, okay? So the electrical team, they need to know what is the kilowatt, how much we need power, okay? In order to do so, so we have to calculate the horsepower and then obtain the kilowatt from this one. So this equation is a rough estimation, okay, for the horsepower and the kilowatt. If you need accurate one, you have to go to specific catalog like Pentair, Gramfos, Astral, or whatever famous brands in this item, and open the catalog, select the most suitable curve for you, and obtain the horsepower and the kilowatt and give it to him. Okay. On the other hand, the like rule of thumb or the rough calculation, I used to do it like that, and it works for all conditions. So if you go to the reality and select the pump, you will find the horsepower definitely lower than the one that I calculated here, and the kilowatt lower than the one that I calculated here. Not far too much, but it give me like rough estimation in order to manage the design. Okay, so the horsepower you can calculate it by flow times head. Okay, divided by 75 meter. This is the conversion factor times the efficiency. The efficiency, it could be like 90%, 80%, 70%, but I always prefer to make it like 0.5 to be in safe side, because lower efficiency, which means higher horsepower, which means more safe. Okay, so it could be also zero point 0.7 or 0.75, like in this example. Okay, okay, so using the pump power formula, we can obtain the horsepower. We got it here, 6 horsepower, and then the kilowatt equal normally 0.8 times the horsepower, which is less, 5 kilowatt. So now we obtained everything: flow, head, horsepower, kilowatt. So we size the pump. This is the final selection. Okay. So as I said before, the float was too high. We can make it to 2 working and 1 standby. The 21 liter per second we divided by 2. So each one of them will be 2.5 liter per second, and one of them will be standby. If one damaged, the standby will cover the required system flow until the other one fixed and installed back. So the total dynamic head, we calculated 23, the power 5, I mean the kilowatt 5, and the horsepower 6 horsepower. Okay, okay. So this is like rough selection. I bring it from the internet. So as we see here, this is like our normal scope of work. How to select the pump, all of you, I believe, expert in this one. But just I will give like high-level explanation about this. This is the head curve, the head axis, and this is the flow axis, and this is the performance curve of our pump. So the best selection, normally, we take it in the middle set. This is the optimal selection that we always consider. And the green one, we call it system curve. And this is normally more important in plumbing, because we have the like variable demand. The demand fluctuate from time to time, depend on the usage of the toilet. But in our case, the system curve almost fixed because the filtration rate constant and the pump working in constant speed. No need to work in variable speed. It will be like wasting for energy and or money. No need to spend the money for something it will not be used. Okay. So this system curve normally in the plumbing, it will go like that. If you see me in the camera, it's like going up and down based on the demand around the curve. So sometimes the flow high, so the pressure will go. The flow high, the pressure will go down, so the system curve will go down, and sometimes the flow low, so the pressure will go up and the system curve will go up. So this is the way that we select the pump. Need to see here. Uh, you see here in this pump we have strainer. Okay, so we need to remember those points. Okay, swimming pool pump should be self-priming pumps. Okay, it should maintain velocity 1.5 meter per second at the suction, and we will discuss this in detail when we go to the part of how to calculate the pipe size. And then the delivery, it could be slightly more. It reached to 2 meter per second. If you remember in the chart example that I show you just now, I consider it 5 feet per second, which is equivalent to 1.5 meter per second. This one in the suction side. Uh, One of the things also, I said this, it should be a strainer equipped with this pump in order to catch the debris and restrict any papers or any big items to go to the impeller. And as I said, also the filtration, the filter losses, okay, from 0.4 to 0.6. So those are the main things that we need to consider when we select the pump. So the pump, it has to be self-priming pump, centrifugal pump. You see, self-priming centrifugal pump. Any question? No question. Okay. So I will go to the next one, the filters. Okay. So in swimming pool system, filtrations, okay, types of filtrations plays a crucial role in maintaining the water clean and safe also for usage by the swimmer, the swimming pool users. So the filtration system work hand in hand with the circulation pump that we just calculated to remove the dirt, debris, the contaminations, the contaminants that I discussed in the last session, to ensure healthy swimming pool environment for the swimmers. So choosing the right filtration unit is essential for maintaining the water clarity by removing the particles, okay, reducing the chemical load also that we need for disinfection, and preventing clogging and damaging for the pumps and the equipment, and in general improving water quality for the swimmers, as I said before. Okay, so in this section of the filters, we will cover the types of pool filtration system and how they work, and we'll see what is the advantage and the limitation of each type of them, and what are the key factors in selecting the right filtration unit. Okay. So the first type of filtrations, we call it the pre-filter, this pre-filter. You see, this is the pump that we just selected. Okay. So the strainer in the pool, this one, okay, in the pool pump, is an important component designed to protect the pump and the filtration system by capturing debris before it reaches to the impeller here. Okay, so this it help preventing clogging because it captures large debris like leaves, hair, and small stones before they enter the pump impeller, preventing damage and blockage in the piping system. And also stopping large debris in the strainer prevents unnecessary load on the main sand filter, which is important for filtration, allowing the filter to work more effectively to catch the finer particles instead of like wasting the energy to catch that large debris. Okay, so this strainer basket can be easily removed and cleaned, preventing excessive buildup that could reduce the pump efficiency. We have from time to time to take it out and clean it, return it back. Okay, okay. So this is the main guy. This filter called pressure rapid sand filter. We need to be careful about this because there are many other filters similar in the shape to this one, but actually not rapid sand filter. If we are using slow sand filter, this filtration system will not achieve the water quality requirement that we need to achieve. So we need to ensure the type of this filter is rapid sand filter. It helps to like achieve the turnover rate that we need to achieve based on the pool type that we have. Okay. So the pressure rapid sand filter is the most common filters that we normally use for the swimming pool, as you can see in the screen. So in terms of the description of this one, it is like closed tank, okay, or closed tank system that forces water through a bed of sand under pressure, as you see here, to filter and remove the tiny bits down to 20 microns. The sand filters, it clean up to 20 microns. This is the accuracy of this sand filter, because we are going to discuss the Cartridge filter that going more like more accurate than this we are going to discuss today. So just remember this: it removes the contamination up to 20 microns. Anything smaller than this, unfortunately, it cross. But actually, we don't need to go more than this for the pools specifically. So, uh, um, so this filter used to remove the fine things like lotions, hair products, sunscreens, tiny algae or dust, all the small things, it will be removed by this filter. Okay. So regarding to the working principle of this one, the water, as we see here, the dirty water in red color, as we see here, enter the filter under pressure because it's coming from the pump. Okay, then it pass through layers of graded sand that traps debris and suspended particles. Okay, so you see this one, it's called multi-port valve. It distributes the water, okay, like shower, consider this like shower, uh, around the whole area of the sand here. Okay, okay, so the water go down, the clean water, the blue one, the clean water go through under drain system. We call this one under drain system. So this collect the clean water because the water once it reach here, crossing all of this layer, it become clean and clear, and then it go through under drain system, go up to the pool again from the center here. So this is the normal filtration process. Okay, so over time, the filter get clogged, which needs periodic backwashing to clean the filter media. So what to do? We reverse the cycle. Okay, you see here in the right hand side, and instead of going around the center, it goes from the center and through this drain pipes, and it go up again. We reverse this one. So all dirt here, it will be flushed out. Okay. So what is the key component here? We have a filter tank, the house contain the sand. We have sand media, typically contain graded silica sand, should be various sizes for better filtration, depend on the layers here. We have under drain system, collect the filtered water, multi-port valve, okay, to control different filter operation, and we are going to discuss it in details now to understand how to use this different option in the multi-port valve. We have inlet here, and we have outlet pipes. Okay, and we need to remember the filtration rate range from 30 to 40 cubic meter per hour for every square meter. Okay, so this is the filtration rate for the pressure rapid sand filter. If we have a slow, by mistake, you accept as an engineer slow sand filter, this will be completely wrong because it go down to 10 meter cube per hour, 5. So we need to be careful this having this filtration rate, or at least to understand what is the design. As I'm talking about the supervision now, if you have a design coming with calculation, and the designer considered this pressure rapid sand filter, and he said given data filtration rates, for example, 35 cubic meter per hour per square meter, we have to achieve this one in the selected filter that proposed to you from the contractor on site. If it is different material, it will be completely wrong. Okay, so this is the thing, and here we now we have a better knowledge of the general operation of the filters, the filtration system in general. So let's have a closer look at how the filter works and learn to use each of the 7 functions here, those 7 here. Okay, available in the it's called multi-port valve setting here. Okay, so these 7 functions are accessible through the multi-port valve. Okay, or we call it Dale valve also, with this lever at the top of the filter. So when you go there, you will find 7 positions. Okay, so once you turn your lever to this one, it works with different function. So first here we have filtration, filter, and then we have rinse, and then recirculate. Okay, and then winter, right, and then backwash and closed waste. I'm going to show you what is the benefit of each one of them. So you see in this video, when dial valve or multi-port valve lever is in the filter position, okay, which is the main function actually that we are using for this filter, the pumps draw the water from the pool to the dial valve, then it is filtered through the sand, leaving the debris, okay, at the surface here, okay, the surface of the sands. So once it's filtered, the water goes through the center, as I explained to you, then returning to the pool again. Okay, so I'm sorry, this video is not the best one describing the plant room. We never do plant room open to sky exposed like that, but this is the best video that I found it that describe the process without confusion. You see, so the water coming here and then collected here and then go up. So over time, and especially if the water of this pool contains a lot of debris, the sand here will become dirty. So this will increase the pressure in the filter. Okay, the filtration process become more difficult. Okay, so once the pressure gauge here become it shows higher pressure than normal, which means we need to clean it, we need to backwash. So this operation called backwash, as we are going to see in the next slide. Okay, so the backwash position. Okay, so this, when the pressure gauge, as you see here, in the first time you turn on your filter, when you have new filter on site, check the position of this needle, okay, in the pressure gauge here. The pressure you read in the first operation is the standard pressure of your filter when it is clean. Okay, for example, if the needle or the pointer indicated 10 psi, you will have to wait until it is indicate 5 more psi, okay, or reach to 15 psi, for example, before we do backwash. Once it reach to 15 psi, which means it is like more dirty inside and it needs to be cleaned. So, for example, if I first time I found the pressure gauge 12, you must wait until 17 and so on. So, as more pressure you have over time, which means more dirt and accumulated inside the filter, and we have to backwash. So to do the backwash, first we have to turn the pump switch to the off position. You see here, okay, The pump must always be stopped before changing the position of this lever, okay, to another position to ensure there is no damage happening in this valve, because this valve very sensitive. Okay, so after stopping the pump, we turn the dial valve lever to the backwash, then restart the pump again and let the flow go out to the drain, okay, or the backwash tank, as I explained to you. So the water in the backwash position, it doesn't go back to the pool, it go to the drain. Okay, so this time the screen is off. 1 second. The screen always do like that. So in this condition, we can see the cycle reversed as we saw in the video. The water coming from the pump will first to go through the middle of the filter, not outside the center, then go through the sand from the bottom to clean the sand, then the dirty, you see, then the dirty water go through the backwash drain. So this one drain dirty, and the green one here is coming from the pool. Okay. So in the beginning, we will notice the water coming from the filter, not clean, dirty, which is normal. So we have to wait until the backwash operation finished, and then we'll go to the filtration position again. Okay. So we can observe this from bottle. Some filters equipped with a small bottle, which is part from the valve. Okay, so we can see from the color of the water from this bottle to see if it is dirty or clean, and uh, the backwash finished, or we need to stay more. So, but in general, this operation takes maximum 10 minutes. Then the backwash will be finished, and the water will be clear. I need just to show you this bottle. You see this bottle. From this bottle, you can see the water is clear or not. Okay, then rinse position. So as usual, stop the pump and turn the dial valve lever to the rinse position. So why we rinse? Okay, because during the backwash, all the sand gathers here in the multi-port valve. And once returned to the filter position, all the sand and dirt here accumulated in the valve body, okay, it will go back to the bowl. Therefore, the rinse function is necessary to rinse this valve, the dial valve or multi-port valve, in order to take it out to avoid making the water color cloudy. You remember the cloudy color that I showed you in the last session? So this is one of the reasons. If you do backwash without rinsing, after every single backwash, you have to rinse the valve in order to ensure there is no residual sand go back to the bowl. It should go to the drain system. Okay. Uh, as usual, stop the pump and restart the pump after switching. Okay. Okay. So after finishing the backwash here and rinsing, the pressure should go back to the original condition. Okay. As I said, if it is 10, it will be, and become 15. After backwash, it will go back to 10 again, and so on. That's why the resistance of this filter, it's very dependent on the condition. So we normally take it like a half bar, 5 meter. Okay. So here in this position, which is called waste, okay, the first position, waste or drain. So this function is used after heavy rainfall, okay, or when the water level in the pool is too high and you want to take it down, lower it down. So if you have too much rains added to the pool, so you need to drain it out. In order to do so, you switch it to this after switching off the pump as usual. Okay, turn the lever to the drain position and restart the pump again. The water will then be drawn to the valve directly without going through the sand, and then it will go to the backwash drain. The same connection. It will go outside our system. So this drain function also could be used at the beginning of the season. Okay, if you keep the pool long time off, not used, especially in cold areas. Okay, so you want to clean it, you want to use the vacuum. So when you want to use the vacuum to clean the pool of large debris accumulated at the bottom of the pool or when you have extra dirty in the surface, you normally use this option. Okay, because if we carry out the same operation of vacuum in the filter position, all the dirt will be drawn directly into the sand and will clog the filter. Then we need to backwash again. Okay, so when you do vacuum in the drain position, the dirt will be removed without being filtered through the sand. So the drain function may be also used to remove uh, algae that may have gathered at the bottom of the pool after algae treatment, if they are using special treatment. Sometimes the algae gets stuck in the walls and bottom of the bowl, so they are using special strong chemicals. So you don't like these chemicals to go through your sandy media to avoid damage it, so it is better to take it outside directly. So in such cases, we use this position. So the fifth position or the fifth function is viral. Any question? No questions. You are still with me? Everybody with me? Okay.
Yes, Khaled. Yes.
Okay. So the fifth function is viral, or we call it recirculate position. So this function is actually very rarely to be used. It is used to circulate the water to the dial valve or multi-port valve, then from this valve to the pool without going through the sand. Okay, so we keep circulating without the sand filter. The cycle will keep recirculating without using the sand filter or crossing through the sand. So this function is mainly used for specific water treatment that using extra chemicals and do not require filtration. So we need to introduce, like what I explained to you just now. Uh, in the previous one, it's called waste connection. If we put like special chemicals for special conditions and we need to circulate this one very quickly, we stop the sand filter and open the pump with full capacity. It keeps circulating faster, so the turnover become much more when you remove the sand, and it keeps circulating the chemicals. And after that, we make the waste connection that we discussed in the previous slide. So also, this function it allows us to check if we have breakage or something broken in this valve. If you see in the video, he was showing like sand in the bottom. Okay, so if you have breakage of any part of the valve that usually causing sand accumulated at the bottom of the pool, so we need to carry out this check. We can carry out this check by using this function. So first, we need to completely clean the pool, okay, to ensure there is no sand, okay, and then switch it like that to the recirculate position and keep it in operation long time, overnight. Keep it overnight working all the time. Okay, you are sure before leaving the pool everything clean, no sand, okay, and then come tomorrow, the next day. If you found sand, okay, which means which means it came with the wind or someone bring it like children, or the sand came from any other reasons except the valve, which means that the valve is not damaged. But if you found sand, which means it's coming from the valve. Okay, okay, this one clear, because in this condition we are not touching the sand of the filter. Okay, so the sixth function is the storage position, or we call it winter. Okay, we call it winter. Okay, the storage position or winterized closed position, it is used to protect the multi-port valve seal specifically during the filter storage period when we stop using the pool. Okay, in winter, specifically in freezing periods, in which is not here in Europe or America. So we use this position to increase the seal lifespan while the filter not used, because the water, if there is water inside this valve, it might expand while it's freezing. Okay, someone asking? Okay. However, this function not critical for us here in the Middle East since we don't have freezing, but I just wanted to let you know if you found it in any filter that you see on site. So now we understand the 5 main filter function and also know how the winter operation is done here in this slide. So the last function we have is the close position. So this is the last one, the close position. In the sand filter, when we do it in close position, we normally use this position for maintenance. If we have maintenance in the plant room to completely stop the water flow through the filter system, so we use it. You can call it like isolating valve. So this position stop water from draining out of the system when opening pipes for maintenance, removing fitting or any filter connection. Okay, so also this useful when cleaning out the pump, strainer, basket, or replacing any part without losing the pool water. Okay, we're almost finished, guys. Here, this how to size sand filter. Sorry, I take too much time talking about the videos. So sand filters, as we know now, normally rated by diameter. When you like pump, when you want to select a pump, you have to know the flow and the pressure. Without those, you cannot go to the market and tell the vendor, I need this pump. He will not understand. The same for filter. In order to go and purchase filter, you have to specify the filter by diameter and the filtration area. I need this much of square meter. I need this tank diameter. This is the way that we need to size the filter. Okay, and we need to know larger filtration area, improve efficiency, and reduce the maintenance requirements. So we need to like make it more. So to size the filter, we need to know. We need to consider this. The filter must handle the pump flow rate and ensure also proper turnover is achieved. Okay, otherwise excessive water or excessive flow will cause poor filtration and many challenging that we don't like to have. So the first step when you size the filter, okay, we have to determine the flow rate. We calculated the pump already, so we can simply calculate the system flow from the pump. So we have 2 pumps, each pump equal specific liter per second. So the flow with us, this is one. The second one, we need to see what is the filtration rate. As I told you, for the pressure rapids and the filter, the filtration rate vary from 30 to 40 cubic meter per hour for every square meter. Okay, so let's take the average 35, 36, something like that in order to calculate it, not oversize it or downsize it. Okay. Uh, and then we calculate the area. Once we have the filtration rate and the flow, if we simply divide the flow by the filtration rate, it will simply give me the area of this filter. Okay. Okay. And then from the area, we can simply bring the diameter and we can specify this filter. As we see here, the area of circle, because it's the cross-section area of the filter circle. Okay, so by times d squared divided by 4, it will give me, from this we can obtain the diameter of this one. Okay, so let's go back to the same example that we used for the pump. We'll continue from here. We have the same pool, same dimension, and the pump already that we calculated. We have 2 pumps, 2 working pumps, 10.5 liter per second. So the total will be 21 liter per second head. So step 1, we will check what is the flow rate. As we said, it will be 75 meter cube per hour or 21 because we have 2 pumps working, and then we can calculate the surface area with the same concept, flow rate, the flow. Okay, the flow rate divided by the filtration rate. Here in this example, I show you 2 cases actually. If you make it in with the maximum filtration rate 40 meter cube per hour and the minimum 30 cubic meter per hour per square meter to show you what is the impact on the diameter selection. So if we take it in the high, range, it will give me this area, 1.89. If we take it in the low range, it will give me this area, which is like 1.5 times this one, which is much bigger. So as low filtration rate, as bigger filters we need to specify. That's why I'm telling you, if the contractor bring to you slow filter, okay, it will never fit to the water quality requirement that the designer calculates. So ensure the filtration rate as per the design intent, the design consideration. Okay. Okay. So after calculating the area, we can simply calculate the diameter. So the diameter for the high filtration rate will be 1.55 meter, and with the low filtration rate, it will be 1.79, which is much bigger. So do your calculation as a designer based on the worst case scenario, which is 30 or 35. Okay. And when you do your selection, you have to ensure the provided or proposed filter with high as much as possible to ensure you are covering your swimming pool requirements. Okay. So here, what I want to show, we almost finished, guys. Don't worry, just bear with me 5 minutes. I know we cross already 1 hour. So here, I just wanted to tell you, for example, 1.55 meter. This is too big to be one filter. Actually, it cannot be like that, and we cannot simply say 1.5 meter, 1.55 meter divided by two. I can make it two filter. We should not calculate it like that. When you want to divide the filters to smaller filters, divide the area. Do not divide the diameter. So you have to go one step back and see what would the total area came and divide it by 2, by 3, by 4, as you wish. Okay. And then from this area, obtain the diameter. You noted this one? This is very important. So when you want to make it a smaller diameters with like more number of filters, you have to divide the area, not the diameter. So from here you can get the diameter that you want. Okay. So the diameter in this case, it will be like 0.9 meter. Okay, with 3 pieces in case of 40 meter cube per hour, or it could be 1 meter with 3 pieces for low filtration rate like that. Okay. So the last one, the Cartridge filter, very quickly. This is the last filter we have, Cartridge filter. So why we need to know this filter? First, the Cartridge filter used to trap debris and particularly from the water usage, as by using a plated fabric like this one you see in this picture, similar to the one that we use it in the air. We call it like a plated fabric or blister element. Okay. The Cartridge filter also required periodical rinsing, not backwash like the sand filter. This provide filtration better than the sand filter. I'm just explaining to you what is the difference between this and the sand filter. Okay, the lifespan of this one usually 1 year, maximum 2 years, and you have to replace it. That's why it costs more. Okay, and when we selected this one, we selected based on the area. Okay, we size it by like square foot or square meter for the filtration media, and as larger surface area provide better filtration and also longer interval between the cleaning. So it depends definitely on the brand and the manufacturer category. So please remember, oversizing in Cartridge filter is better. A larger filter ماشي last longer, improve filtration and require less frequent cleaning. Okay, but we need to know that if we are using sand filter, pressure rapid sand filter, the Cartridge filter is not necessary for pool filtration, as both serve the same purpose, both of them doing the same. So however, both of them have pros and cons. The sand filter, for example, it can capture up to 20 or 40 microns, as I told you before. But the Cartridge filter, it go down to 10 microns, which mean more better filtration. But we don't need that high level of filtration in a regular private pool or public pool. We could use it in a special pool like hydrotherapy, okay, to add more better filtration, something like that. So sand filter usually is enough for the pool. No need to provide Cartridge filter, but if you need it, it doesn't cause harm. and the sandy filter is sufficient for whatever you need to design the swimming pool. Uh, what else? Now I finished. Sorry for taking so long, but we will continue in the next session. Guys, you are still with me?
Yes, yes.
Oh,
It was interesting, Khalid. It was interesting.
I believe you are the only one, Ahmed Manhaj. You are focusing with me. Nobody asking. I feel the people
No, we are listening, Mr.
online and
Khalid.
No, we are also
Yeah, yeah.
listening. Yeah.
okay. So any question or you get tired? You have the opportunity to take the lunch. I'm not having this opportunity. I have to keep talking. So
No,
whatever
very
bad situation
informative,
you
sir.
feel, it will be better than me.
Yeah, when we actually do the practical, maybe we will have some questions while using these formulas and all. No? So then we will ask questions actually.
Okay, good. So now